Hello, I'm Andrew. I work at GitHub and I live in Bath. I've only been at GitHub for about 6 months now, so I'm still kind of green around the gills. But I'm not talking about GitHub today. I'm talking about Nodecopter, obviously. I also, a little bit of background about me. I organise and run the London Node user group from Bath. I used to live in London, and when I moved down here, I didn't really let go of it. And so every month, drive up and kind of organise it, and then drive home afterwards, about 2 a.m. So, Nodecopter, it's kind of like a combination of a range of events, which are hack days, where people get together and hack on flying robots, and a Node module called AR Drone, which is actually a library and interface for controlling these AR drones. So it kind of crosses both things as being an event and a library. And today I'm basically going to give you an overview, do some demos, and see how deep the rabbit hole goes of stuff that I've been playing around with for about a year now. So this is kind of your average Nodecopter event. A number of AR drones, some tape on the floor so that they basically can have a better recognition of where they are. They have a downward-facing camera that they need some kind of texture to be able to recognize if you've got a very smooth floor. They'll just drift all over the place. And people will get together in groups and hack on them to produce some kind of fun little project. It was started by this handsome German guy, Felix Geisendorfer, for JSConf EU 2012 as a hack day. He basically was tasked with setting up some kind of a pre-conference event. Looked around the room, he had been given one of these for Christmas. He was like, I wonder if I can program that with JavaScript, and started building off of the API docs for the iPhone app for controlling it. Produced a Node module and presented it here. This is his first ever time presenting it, which is why he's catching it in midair because he couldn't actually get it to land. And since then, it's come on kind of leaps and bounds, and Parrot have really helped support the kind of the movement as well. So let's talk a bit about the AR drone. Specifically, this is the 2.0 version. The 1.0 doesn't have quite as many features built in. The camera very poor, and the API doesn't really give you anywhere near as much kind of ability to control it. So we basically only use the AR Drone 2.0 at this point. I brought a couple along with me, mainly because you never know if one is going to break or not. The interesting thing about them is they're absolutely full of sensors. It's basically a flying Android phone. So we've got kind of a protective polystyrene layer over the top to absorb any energy if you crash it. And then 4 motors and blades, a HD camera on the front, a low resolution camera on the bottom for doing optical flow. It's kind of similar to a laser mouse. Ultrasound sensors, and then internally accelerometers and a digital compass to work out which way it's facing. And it also runs Linux. So it's a BusyBox Linux version running internally. When you plug it in, it just boots up and it shows up as a Wi-Fi hotspot. So you can connect, the idea is you connect your iPad or your iPhone to it, and then it exposes an API over a UDP socket so you can send it commands and stream video back to it. But it also means you can connect your laptop to it. You can even connect other devices or drones to other drones, because it's just, if you start thinking of it as like a router that happens to be able to fly, you can kind of do all kinds of things with it. And Parrot have documented this interface that it sets up, mainly so other people could build iPhone apps. The code examples they have are in C or Objective-C, and the AR drone library for Nodecopter that we use is like a JavaScript translation of that in a much nicer way. And these documentation kind of files and things aren't really well updated at all. So a lot of the stuff in the API ends up being reverse engineered, where they've updated their apps but not told anyone how the new features would work. Things like they brought out a GPS device you could plug in the top of it and give it a GPS. They never told anyone or updated this documentation at all, so we had to reverse engineer how you would tell it, or how you would find out where it was in the world. And it's still pretty buggy because we just don't know how some of that works. So, imagine being a JavaScript group. Some of you are aware of Node.js. I get a show of hands for people aware of Node. Excellent. So this is the official description from the website, which I'm not going to try and read out, but it's just full of buzzwords. This is how I consider Node to be. It's JavaScript outside of the browser, running on top of V8, so basically Chrome without any of the Chrome. Asynchronous by default, so everything is going to be callback-based or event-driven, which is perfect for something like a robot where you're waiting for feedback from it, and potentially that could take some time. If you've got spotty Wi-Fi or interference, that you're not going to want your program sat waiting to hear back from the robot before it does something else, because that could potentially just mean you crash into a wall. And any other kind of network program. So this is why you see people say Node is so fast. Programmatically, it's probably pretty similar to a lot of other languages. It's just that it handles doing I/O, network, or disk I/O really well, because it just schedules it all for you and you don't have to really think about it. If you haven't already tried it, it's really easy to install. As programming languages go, it works really well on Windows. Just using the installer, which surprised me, coming from a Ruby background where it's really hard to get Ruby running on every different platform. And then you get a Node command in your terminal, which gives you a JavaScript record similar to the Chrome inspector that you'd be able to run JavaScript in. And then it also comes with a package manager called npm. And to get the library to control the drone, it's just npm install ar-drone. And there's all kinds of modules on npm for doing all kinds of things, as well as a load of other extensions to do more interesting stuff with the ar-drone. So using that ar-drone module, this is like the hello world of Nodecopter. This is all the code you need to get it to take off, to fly up in the air, to spin clockwise, and then come down and land. Don't think we really have enough room in here to do flips, because it really does go up in the air quite a lot when it does that. And I don't want to break the roof, which doesn't look particularly solid. But I'll try. That's it. We'll see how confident I'm feeling after some of the other demos. And this is really all you need. So you can see how simple this is to get started in robotics. But this is just like regular JavaScript. There's nothing really special here. The only thing that you might notice is with this after function, this is basically a convenience way of chaining a load of set timeouts together, so you don't have to nest them together. So when the time is finished, it will call that function, and then it will start the next after call, waiting for another 2 seconds or 3 seconds. And then this is really cool. You can actually run Nodecopter in the browser. So this is a project, you can't really see it in this light, but there is a browser there somewhere, that produces a Minecraft-like world in a project called Voxel, and drops a block-based AR drone into the world. And if you open up the JavaScript console of your browser, you can take that same code here, except for the top 2 lines, and run it, and that will actually act out all of the same commands. The only thing that it does slightly differently is that physics in that world is perfect, and there's no concept of momentum. So when you say stop, it stops instantly. we say stop to that, and it's going at full speed. It takes a few meters before it actually comes to a full stop. But it's a really nice way of either trying some code out before you actually fly on the live thing if you don't know what's going to happen, or what is the beat?
Thank you, just authoring it. Don't get too excited.
Just hungry. Or another use that we've tried is introducing kids to this, because kids love Minecraft. If you combine that with flying robots, then that's kind of a really good incentive for learning some programming to be able to fly a robot around your Minecraft world. So, going to do some demos. I've got a few different demos. I did have an Xbox controller demo. This is my rabbit, Webrtc. Fortunately, he now has the Xbox controller after chewing through the cables, so I don't have that one.
Do you need any Xbox controller?
It needs to be a wired 360 Xbox controller. They're Xbox Ones, I've already checked, unfortunately. So, as you've already signed one disclaimer, another one is that it is a flying robot. It does have 4 spinning blades on it, and demos can occasionally go wrong. People at the front row, especially kind of adventurous to sit there. So it should all be fine. If anything goes wrong, the easiest thing is just move out the way of it, or you can grab it top and bottom, flip it upside down, or you can kind of just push it away. Don't stick your fingers in the spinning bits. Doesn't matter how many times I say it, someone always tries to grab it by the moving parts. It's actually probably one of the most kid-friendly drones you can get, or quadcopters. Even if you go smaller, they don't have the same safety features. If it senses any of the blades have been blocked, it turns off and it just falls out of the air. If you stick your finger in one, then it will just shut off. It will hurt, but it won't cut you. It's quite a flexible plastic blade. And if you flip it upside down, or even slightly more than vertical, then it also turns off, which is another kind of convenient way of shutting it down. It's just to grab it, flip it upside down. All right, and here's one other demo that I can't run. After upgrading to the latest version of macOS, I can't get OpenCV to work properly with this demo, no matter how many times I try, but we'll come back to that. Alright, that's probably really small and hard to see. Okay, so here's a slightly, can anyone read that? Or is that just really... This is a slightly extended version of that hello world, where we're just doing a number of different commands after in sequence. So basically just telling drone do one thing, and after a few seconds we tell it to do something else. And it will continue to do one command until you tell it to do another one. So if I select the name of the drone, and all of the quadcopters that I have are sponsored by a company, basically. This one is a company I used to work at called Forward. And they basically sponsor a drone for as long as it lives. So far I've only had one that has died completely. So it turns out to be quite a good sponsorship deal, because for £250 for a drone, and then maybe kind of £60 for some batteries, that'll cover 10 Nodecopter events. So it's a pretty cheap investment for these companies. So I'm connected to the drone, yep, and it's literally just a case of running this JavaScript file. I don't know where it's going to go, what it's going to do. Hopefully it won't just come down on someone's head. There we go. So that wasn't autonomous at all. It didn't pick on you in particular. That was just how it was pre-scripted. I think in probably the last place I ran it in a slightly larger space for it to fly around in. So that's kind of like the starting point. Really nice way to get into it. What we can also do at the same time is stream video back from the drone, as well as other sensor data. So, let's see. So I'm using a project here called Drone Stream, and this is a little bit crazy in the way that it's set up. Let me start it up, and it runs as an Express app, which is kind of like a small, easy to set up web server inside of Node for doing kind of general websites and things. So that starts up, it connects to the drone, and it starts a web server at the same time. So if I go to my web browser, yeah, if you move your feet around, then we can see it's actually live video. What's happening here is every frame of video that the drone it's not recording, it's not saving it anywhere. It's just pumping it out over the network to my laptop. The laptop is then taking that frame and pushing it up over a WebSocket to the web browser. And in the browser is a project called Broadway.js, which is actually kind of, I don't know if it's magic or Ruby or something. They've taken the H.264 decoder from Android, cross-compiled it into JavaScript, and then they run it on the browser. So it's actually decoding the frames of the video, the H.264, into pixels and then inserting it into a WebGL canvas element. Now, I didn't make this, I just hooked it up so you can view it as a demo. That seems kind of wild and crazy to me, but it works really nicely and you get really high frame rate, assuming you only have it open once. If you open 2 tabs simultaneously, Chrome kind of dies and gives up. But at the same time, we can leave that one running, and so that's on a separate port, that we can actually send it commands, make it fly, and do basically the same thing again. Sorry. So if we just say, and then swap back over here, we actually get a reasonable video feed. Oh, you're down on that chair. Not bad. While doing video streaming. What I'd usually do, if my rabbit hadn't eaten the controller, was then fly it around using the Xbox controller. Instead, let's go. I've lost a tab here. There we go. Instead, let's use this project called Webrtc. What this does, if we start it up, is similar kind of setup. It starts up an Express web page, and it does a video feed in a very similar way. But it also starts feeding the raw sensor data from the drone up into the browser. So we can then start visualizing more information that it gives us. So we've got things like, the battery is at 38%. Most of this stuff only actually starts changing when it's in the air, but we've got the angle that's facing, its height from the ground, which is, I think, the green one over there, and its approximate compass bearing. Here, I twist it around, you can see the compass moving at the bottom there. And this gives you keyboard controls to fly it around, so you can drive it from your keyboard. Or if you've got like a PS3 controller, you plug it in and use the gamepad API. So it acts as kind of a nice pluggable interface, you can build different components to add into this. So like the battery is actually a component that you can turn on in the configuration. When you start up, it shows the battery. You can swap out the way the video works. You can even add in, if you have an internet connection, a slightly time delayed data feed from planes in the nearby area will be laid on top of the video feed in a kind of augmented reality way, so you can see, there's a plane like 1 mile off over there. As you spin around, you'll see different planes. But I haven't got an internet connection on this laptop whilst I'm connected to the drone. That takes a little bit more network hokey, which I'm not trying to do for a demo. But if I can remember what the key is. Can I remember what the key is? There we go. So I've got WASD to do side to side and forwards and backwards, and then arrow keys to go up and to rotate. And these are the kind of commands that you'll get through the API. You can basically say rotate left, rotate right. And so I can actually, sorry Lauren, kind of like a personal air conditioning system. Sorry, maybe it does like you. We don't have any video feeds. When do I have one? So that's an interesting thing. If you fill your program with, it doesn't necessarily mean that, so I'm no longer controlling it. But when you do reconnect to it, it basically sets it into a state where it's like, I should be on the ground now, and it will come back down, which is kind of nice. When it runs low on battery, it will do the same thing, which is all built into the firmware that runs on the drone rather than part of the AR drone JavaScript library. It actually does a lot for you on board, which if you were to build your own, you would end up having to write that software yourself. Okay, so we can do keyboard control, we can stream some video. The next obvious jump for me is to make it dance to dubstep music. That was just where I went to. So what we're going to do here is get a piece of music and try and get it to dance in time with that piece of music. And in a similar kind of way, we're going to have a web server, which this demo is written in CoffeeScript. I don't know how people feel about CoffeeScript. It seems to be split the room half the time when I talk about JavaScript places. And it kind of gives you exactly the same setup. Express server and a WebSocket, which allows you to send commands to the drone from the browser. If we start this up, no? Cat, yes. So what we've got here is a CSS3 speaker, like a subwoofer, and one button. What's going to happen is we're using a library called Dancer.js, which uses the HTML5 audio API in a really cool way. It gives you essentially a callback every time there's a drop in song. So dubstep works really well because there's lots of big, bassy noises that will give you lots of obvious callbacks. And basically every time we get a beat, we toggle going up or down with the drone, and so it should bounce along in time with the music. The audio was working fine earlier, so let's just assume it worked. Sorry, Lauren. So this is flying pretty much autonomously now, but it's not really taking any feedback in from the world around it. I don't know why it's got a little wiggle on either. Shouldn't have that. You can see I'm also animating the browser slightly to bounce in time with the music, so you can kind of get an idea of when that's happening. And then if we stop it, it should just come back. Which is kind of cool. So those are like some of the easier demos that I've put together. You can get quite advanced. You can even control multiple drones simultaneously if you can connect them to some kind of shared open Wi-Fi, which we will look at in a bit. But I'm not going to fly 2 drones simultaneously today because it turns into a little bit of a nightmare. This was a plugin that I made that would detect faces. So for the website project that I just demoed, and whenever it saw a face, it would put an image basically over the top of it. But having trouble with OpenCV recently since I upgraded my laptop, and I just can't get it to work anymore. But taking the video feed and then pumping it in something like OpenCV or some other kind of image recognition library means you can then start to look for things around the room or colors, or even if you were to put an IR filter over the top, potentially some kind of infrared light as a beacon. Then you can do things like this. Probably the only valid use of a QR code I've ever seen, where the command that the drone is going to follow is encoded into the image, and then shown to the drone, it feeds that image back into the laptop, which decodes it, and then sends it back up to the drone and tells it what to do, which is kind of cool. You can also control the drone through the medium of interpretive dance. A dance mat is actually pretty much identical to a PlayStation or an Xbox controller, and there's a Node module for a PlayStation controller, so we just use that. And then you can kind of take your front, backwards, forward, left, right, play some Gangnam Style, and have it dance along the time with the music. We then mapped multiple directions. If you press forward and backwards at the same time, it should do a flip, or if you press one of the directions, one of the angle directions at the same time as forward, then it will do one of its custom animations. You can see it here kind of spinning around odd ways. That's a built-in function in the library to do that. Here's another slightly more complicated demo to set up. What I've got here is a Connect set up in front of my laptop, and I'm basically mapping the position of my arms relative to my body, sending different kinds of commands. What I love here is the guy walking across the background. It's like flying robots. I don't care about that. If I put my hands above my shoulders, then it would go up. If I put one hand in front of myself and one behind, it would twist. So you kind of have this like almost as if I was flying in like the snowman kind of simulator. And the idea was if I move my head higher than the start position, it would also flip in the air. But the Connect can be kind of funny sometimes if you move around in front of it a lot. And it basically just went, oh, Andrew's gone. I'm just going to stay there. But eventually picks you back up, so then it works quite nicely. And you can build all kinds of different control mechanisms for these things. It doesn't have quite enough sensors built into it to make it really interesting autonomous projects. You can kind of make the starts of things, but really to get more clever autonomy, you're going to need some kind of external camera. Potentially even using a Connect pointed at the drone would give you enough feedback to have it kind of give you a real-time position of where it is, because it doesn't really know where it is in the world. It knows what the ground looks like when it's flying, but it can't really map itself out the whole room as it flies around without you building some more advanced robotic stuff on top of it, which does happen within universities, but they never release any of the code open source, so kind of finding the time to build some more advanced things. Or you can treat it as like an API and mash it up with other things. So here we have, you can just about see a laser point kind of moving around the screen and two drones simultaneously. Down here we've got an Arduino, two servos and a little laser pen, and it's basically trying to play robot laser pong where the drones map to the paddles of the game and the laser is the ball. There's one guy sat like down here, and it looks amazing to him because it's perfectly aligned. But everyone else, like, there's just two drones kind of bouncing around the stage. It also kind of shows up some of the problems these drones have with reflective flaws. If they can see themselves in their optical flow, it really screws with their mind. They don't know where they're going.
Self-aware.
And as you can see, they'll just troll the presenters of this hack day, where it's just trying to smash the TV constantly. And we put these pieces down on the floor that it can automatically detect, but it wasn't interested in doing anything that day. It can be quite temperamental. This was one of the first demos from the original hack day JSConf EU, which is turning it into a bull. It basically, once it detects enough red in the camera, will just charge forwards. This is made by Substack, who's pretty prolific in the Node world, releases a lot of modules, and always had quite a lot of fun with it. And then there's someone on the keyboard actually turning it around to face him. So this is where it gets really interesting. You can actually telnet onto the drone. Because it's running Linux, if you're connected to the Wi-Fi of the drone, its IP address is by default this. So you can just telnet onto it and then start playing around with it. I'll put some basic stats if any of you are into Linux. Then it kind of gives you a little bit of information about the kernel version, how much disk space and how much memory and things there are on there, the version of BusyBox, which, as far as I can tell, has never been updated since they released the first version. Like updating it from the iPhone app won't actually recompile the kernel on the drone, which is probably a good thing for something you bought from Amazon. It's also running FTP, so you can FTP files onto it. You can, so this is kind of me trying to move different files onto it. It puts everything in this video folder. You can plug a USB stick into it, and that will actually show up inside this directory as well, because there's a USB port on it. The only thing is, for some reason, on this version of BusyBox, tar doesn't work properly, so you can't just copy a whole folder over the Wi-Fi. You have to get it on via a USB stick or just deliver one binary, because there's no way you could unzip a folder of stuff, unfortunately. And I can't tell if they've done that on purpose, because they don't want you doing stuff like this, or if they've if it's just a bug that they've never wanted to fix. Because this kind of stuff will start to invalidate your warranty. If you were to buy one, obviously these things have already been trashed, so it's not really a problem. This is me plugging a USB hard disk into it. Nope, it's upside down so that it can't accidentally just take off whilst it's plugged into the hard drive. So that would be disastrous. And I copied over the AR drone folder, which is actually the Node module that I was using on my laptop to control the drone. So we can just put arbitrary JavaScript files on it, because it's just a Linux install. It's literally like a server in the cloud, flying around in the cloud. And Felix, again, had already played around with this by the time that I got to it. And he had cross-compiled, because it's an ARM chip, and his laptop is Intel. When he compiles Node, it only works on, the Node binary only works on an Intel machine. So this actually runs a Vagrant. This project, which is on GitHub, runs a Vagrant VM, which compiles the Node binary for an ARM chip, and then copies it onto there over FTP. So then you have Node running on the drone, not remotely controlling it, but actually being able to execute JavaScript files on board the hardware. So that's basically the 3 commands that you need to run, and that will, if you're connected to the drone, you also need internet connection to that. It will actually copy the Node binary across in a really easy way. That's what it looks like inside. It basically is going, I'll spin up the VM inside of Vagrant, and I'll copy out the file after I'm done. Then I'll FTP it over. I'll move it into the bin directory and make it executable, and then I'm done. So I've put a couple of files onto this drone. We've got one which is just outputting all of the data that is received by the drone, and it writes it in a very simple web server. So I'm trying to do as little as possible. There's very little memory on the drone, about 250 megabytes of RAM, which is used up mostly by the software that's already on there. And Node likes to take up a fair amount of memory when it gets started. But I can actually connect to the drone now over Telnet. Yeah. And you can't see the blue at all. So what we can do is go into our data directory. Look in there. Got the video folder. So I'm now poking around inside the internals of the drone. Interestingly, police notice.html is a file which is there to basically say, like, you probably shouldn't be flying this around in public. Tucked away conveniently inside of the drone. Because the police, the first thing they're going to do is try and town it onto the drone after they confiscate it from someone. And then because I've got the USB stick plugged in under the cover, I can go into the USB stick. I've got some films on there, but I don't think it will play unpaid films. But we've also got the AI drone module on there. And in my examples directory, so I've got the Node binary is available. It takes a little bit of time to start up, but we can do standard JavaScript, which works in standard, as you expect. It doesn't, I believe it will work with most, there's no limitation there. It's Node as you'd expect. It's just with no extra libraries or anything that you'd expect on a fully featured computer. And then we've got Pres 1 and Pres 2. So let's try running Pres 1. Yep. And when that eventually starts up. So this is now running a web server on the drone. I can go here, and it's not very interesting. We haven't got a WebSocket or anything. I haven't set up anything too advanced. But what we're doing is outputting all of the data that comes from the drone as JSON. So if you focus on one of these numbers down here, as I move the drone around, we're getting different outputs. So that's like the very basics of starting to do something where the drone could actually fly itself without any intervention, without the need for a laptop. So let's actually try and make that happen. So I've got a second file, which is going to do the same thing again, but then it's also, as soon as it's ready and serving up traffic, it's going to take off, and it's going to spin clockwise, and then it's going to stop and land, because anything more than that, when it's flying autonomously, who knows what could happen. because I wouldn't just be able to stop it without telnetting, making sure the telnet connection is there, and then running a stop command somehow. So let's think about that. Press 2. Kind of move it out the way a few. The great thing about this is, once I've started it, I can actually close the laptop, and that's just running on board, but written in JavaScript. Completely autonomously flying itself. Who knows? It's on its own. It did it itself. And bring the laptop back to life. We should be able to see it's still running the web server. It says, you can see here, it says it's landed now. And you could potentially run similar kind of projects that I was running from my laptop. You do have to take a few bits of extra consideration in. There's no FFmpeg. I wouldn't want to try and compile FFmpeg on there either. For one thing, it would be incredibly slow, and it would probably also take up all of the disk space on there, which is not very big. But you could then start serving up maybe a basic web interface that would give you some interesting data as it's flying around, or even using its own sensor data to then go like, hi, I believe I'm, I can't see, the drone will actually, I don't know if you can see it here, but the drone actually will try and detect when it's close to something based on the video feed, all built in on board, so it could potentially fly up to a surface, sense that, turn around and fly off somewhere else. All while mapping its trajectory and other things and drawing it on some kind of a map. But let's kill that process. We already did that. I forgot about that. You can go even further with that. Max Ogden then plugged an Arduino into the USB of the drone so that he could then start to control extra bits of hardware that were plugged and attached onto it. With mixed results, Parrot uses their USB socket on the bottom of the drone to output debug data. So you can send it commands from the Arduino, but you can't read anything from it because it's constantly sending debug output across USB, which means the Arduino is, I can't understand this, I don't know what to do with it. But there's potential for some stuff there, but probably you're going to end up going, the air drone is probably a little bit restrictive for me. I should use something a bit more advanced if you're going to start trying to build claws or extra like light arrays on an AR drone, because it can only carry about 100 grams of extra weight before it can't take off anymore. And this is the kind of ultimate conclusion of how far you can go with AR drone is another Substack project. It's called Webrtc. This basically takes that concept, wraps it up into a neat single executable, which is copied onto the first drone. That takes off, starts flying around the room, looking for other AR drones on the Wi-Fi. It will connect to another one. It will copy over its node binary, tell it to restart, which then takes off and starts going around, and you basically end up infecting every drone in the room and having them all become kind of one big network of autonomous drones, which obviously ends up in Skynet. But that project's up on GitHub. It's quite interesting to look into it and see how he's done it, because it took a little bit of jiggery pokery to get all that stuff together. And another interesting kind of area that I found is really good for this stuff is teaching kids about programming, trying to get them more engaged, than rather than doing hello world or CSV parsing. If their initial hello world program can make a robot fly around the room, it's going to be super engaging. And we took some drones to a Coder Dojo, which is like a kids coding club, very similar to Code Club, but it happens on the weekends, and it's much more kind of free. There's no syllabus like Code Club is always like, you must do Scratch. This is kind of like free for all. Every month is a different kind of thing, and anyone can run one from anywhere. The parents have to come along with the kids, which is the way that kind of it works to be available for anyone. Little video from where we put the drones along. We started them off using that voxel project so they could try out flying their drones in Minecraft before we let them loose on the drones. We've got kids building tinfoil controllers in the back. We've got girls setting up ballet dances for the drones to do some kind of dancing. We've got one kid chasing his sister around the room with one on an iPad. Basically complete mayhem, but incredibly fun and a really engaging way of keeping them interested, which most coding clubs is kind of hard, especially previous coding dojos, to keep kids' interest for 3 hours in something like JavaScript that they are like begging to do more and more. After 3 hours, we're like, right, we're done now. We're all exhausted. And they're like, no, we need some more. So I think that potentially has some, apart from the safety implications, has potentially like opportunities to go into schools. They've got really good sports halls. Potentially put like a net down the middle of the room and fly on one side and kids sit on the other. I think it could be quite fun. It's just a case of kind of finding the right schools that would be up for doing that kind of thing, or like experimenting with it to see if it has any legs. Or maybe not flying robots, but a similar kind of process with robots that are on the ground with a nice JavaScript API that they could get started with. And just kind of wrapping up now, Parrot recently announced that they've got a new drone coming out. It probably won't be out till Christmas, which is going to replace the AR drone. It's called a Bebop, and it's like a slightly smaller version. It's going to work in a very similar way. The interesting thing here is it has a 180-degree fisheye lens on the front of it, which means it can kind of see everything in front of it, but you don't get the whole view at the same time. It actually does onboard video stabilization, taking a small shot of the whole view and keeping that fixed. Very similar to how it uses its downward-facing camera, looking for one particular shape, try and lock onto that, but doing it with the front-facing camera, which means you don't need lots of weight for gimbals and moving parts, and it allows you to do all kinds of interesting stuff. It also has GPS built in, which means flying it outdoors becomes a lot more accurate, and they've already announced that there will be an API. Hopefully we'll get one before they release them so that we can get the AR drone library working with this as well. But who knows if that will actually work out. The other thing you can do with it is hook it up to an Oculus Rift. This is using their kind of extended controller, which gives extended Wi-Fi range of up to 2 kilometers apparently, which is insane.
I think it's 4 actually.
4?
Yeah, it's 4.
So these generally only have a Wi-Fi range of about 50 meters to whatever your laptop can reach. So if you can get like an extended Wi-Fi card that will give you slightly more range, then that will work. But with this, you basically plug your iPad into it. It gives you nice physical controls rather than a touchscreen, and you can talk to it from miles away with GPS. And the Oculus Rift is going to be not moving the drone with your head, but moving your view inside of that 180-degree image. I can't wait to get my hands on one. I think it's going to be really fun. I think that's pretty much it. So all the details and all of the links to the demos that I've done today and loads more are on nodecopter.com. This is also where all the upcoming events are announced. I don't know when the next one in the UK will be. It'll probably be September time, just because I'm trying to organise a venue space and all of the promotion around it takes quite a lot of effort. We do this completely as a non-for-profit, organised by just a few people who are scattered around the world, so it's quite hard to get them locked down. But if you're interested in getting involved, the whole organization is done on GitHub as well, so you can just open up an issue if you want to do an event, or if you want to get involved in other ways or fix something on the website. So that's pretty much me. I'm T-Bass on Twitter. That's not a Nodecopter, it's just a regular quadcopter that's got a taxidermy cat wrapped around the body of it. The guy who did this,
Very sick.
well, it was his cat until he figured it after. So he was like, he got a lot of press when he did that. And some people were,
died first.
yeah.
Or did
You
you
didn't
just
kill
fly
that
up
for the podcast.
fly it up the cat?
And he then was like, okay, I can go bigger than that. And he, I don't think this is a real ostrich. Look at its face, it's really menacing. But if you saw that flying towards you, right? Also, those blades are wood, and they would take your arm off, I think, if you got too near it. That's all I got. Thanks very much. Has anyone got any questions?
Have you used any other drones?
The other drones that I've tried, a very small one called a Crazy Fly, which you connect to over Bluetooth, about $150, and it's tiny. And the smaller they are, the less momentum they have, which means that they can stop really quick. They can move around really fast. It also means they're incredibly hard to control. So they just zip all over the place. And when they crash, they break almost instantly. The rotors are really flimsy. The whole thing kind of falls to pieces. These are really nice. As you can see, I've taken it up lots of times. I can just bash it into things and it's still good. And I've also tried out the DJI Phantom, but it doesn't have an API. Just flown it with a controller. But it's a really nice one for flying outdoors. It's much more stable for doing aerial photography. There's a few people in Bath that have them, fly them around over the. Yeah, a little bit more expensive than these. These will fly outside, but if it's windy, then they get really buffeted around. And you've only got 50-meter range, so you're not going to get particularly high up before it either decides, oh, I've lost connection, I'm just going to go wherever I want, or it ends up in a tree, and the video quality is not as good as, say, if you were to attach a GoPro, which you could tape to one, but then you'd make it very unstable. The Phantom is much stronger.
Have you done any experiments with Webrtc?
I have not.
On board?
That would be quite cool. It doesn't have a microphone, so you'd only get.
I mean the data stream more than anything.
I've not tried anything more than the demos I had today, running stuff on board, but that would be quite an interesting way of having a mesh network or multiple drones talking to each other, which would be very cool to do.
Nothing. Can you make it flame?
I can try making it, but let's see, how do you get out of time? Okay, so
On your phone, you had a front.
front is forwards, go forwards.
Alright.
It was written by a German guy, so it's all a little bit broken English occasionally. And some of it maps to the documentation, so there's some slightly strange behaviors in the API. If you want to set a speed, it's between 0 and 1, which is relative to the speed that's set by the iPad app, which is in meters per second. So you kind of go with the defaults usually, because there's no real way to set that by the API. And a nice, like, I just want it to go forwards at 1 meters per second. So you have to keep changing the default and restart the drone if you wanted to change the relative speeds. So let's have a look. In my demo, we want to say let's not go forwards. Oh, this draft.
Does the library support promises?
I don't believe so, but you can draft it up. Just get one of the nice libraries like Q, that will promisify your callback function. So you do animate flip, say flip left, and slightly strangely, an amount of time that is basically an animate function, which would be like, oh, animate doing the wave or kind of a weird spinny roundy thing for this amount of time. The flip uses that animate because it's the same kind of call to the API, but time doesn't really matter. If you set it really long time, it will continually flip until that time runs out. But that usually means it just ends up on the floor. Okay, let's give this a try. Don't need to do anything else afterwards. So if it just hovers there, it means that the flip has been disabled and I need to turn it on with my without enough space, you can see it basically drops a lot when because it turns upside down, it turns its rotors off and then tries to recover. And there's without getting it nice and high, and it's likely to hit the ceiling and then it will just drop. But you can see you can do a flip and it will flip in any of the 4 directions. And it will use up a lot of battery power when it does it and tries to recover. Any other questions?
Could you run Node on the device? Does that mean you could actually control it via WebSocket from the browser? So you could
Yeah.
command socket.io.
Yeah, definitely. So you could run socket.io from the drone, and then you connect to it, you open it up on its IP address, and then socket.io will be running on some port that you could send commands down over. So you could do a very similar, you could run Webflight without the video feed from there, I believe. I've just not tried to do it before. Some dependencies in Node end up, like the tree of dependencies has some random one which has a C binding to some function which may or may not compile. There's no GCC or anything on the drone, so it can't compile itself. But you could just copy across. You could build all of the things that weren't platform specific on your laptop, copy them across to the drone. So you should be able to do that. Did you have a question?
Yeah, so I guess it would enable a lot of things that have more awareness of where it was in the world. What kind of things could you do? What options are there?
So you could use.
Aware.
You've seen the videos of drones where they kind of play tennis with each other and do all kinds of crazy things. There's a few on YouTube if you search for like drone tennis, where one playing tennis with each other. They're using stereoscopic cameras around the room that they're in to give a proper feedback system.
So the external thing feeding information to it about where they are.
Yeah.
That is monitor the drone itself. So it's not the drone being aware of where it is.
No, not so much. Another way you could do it with the new Bluetooth low energy. I forget what they're called. You get like a little block that you can stick somewhere, and it is a Bluetooth beacon, which with 3 of them allows you to triangulate where a device is that has Bluetooth. That will give you a really nice indoor positioning system that you could approximate. I'm here in this room, but you need to find a way of getting Bluetooth onto the drone, probably with an Arduino, or getting a different drone, which is a bit easier to put that kind of stuff on. Yeah. Alright, that pizza is smelling good. So, unless anyone else, you can always come up and ask me questions. We'll be around for a short while. Thank you very much for having me.
Thank you.